Hey everybody, in this video I'm going to go over how to draw a force diagram and how to write a sum of the forces statement based on that force diagram. So let's do 3 different examples. Okay, so let's imagine in our first example that we have a boat. Actually, let's draw the boat over here. And it's floating on the ocean, but it is tied to a dock. Okay, you can see that I'm no artist here. You don't need to be an artist. And let's say the current is going in this direction. So my first step is to just draw my situation out, which I have. I have my boat, it's tied to a dock, and the current is pulling it to the right. And now we want to circle my object of interest, which is my boat, and put a positive and negative direction. Okay. Now I'm going to list the objects that interact with the boat. Okay. And that'll be the objects that are exerting a force. So anytime any 2 objects are in contact with each other, that they touch each other, they exert a force. So we're looking at what are the things that are touching this boat. And so one I know is the water. I know the dock is. I know the current is, and I know always we're going to add the earth. Because even if an object is not in direct contact with the earth, if it is on earth, the earth exerts a force on it. Okay? So we always include earth. And we've also included the water, the dock, and the current because those are other things that are touching the boat. So now let's try making our force diagram. I start with a little dot, and that represents my boat. And now I'm going to go through each of these and figure out what direction is it pushing the boat? What direction is it exerting a force on the boat? So let's take a look at the water. Well, the water is underneath the boat, and it's keeping it up, right? If you got rid of the water, all of a sudden the boat would fall to the bottom of the ocean, right? So the water is exerting a force upwards. So I'm going to draw an arrow up and label it F, water on boat. Okay, we got that. All right, next is the dock. Well, the dock is pulling the boat in that negative direction, right? It's keeping it towards the dock. So I'm going to draw an arrow in that direction and label it force dock on boat. So we got that. Okay, let's look at the current. Well, the current we already said is pulling in that positive direction. So I'm drawing an arrow to represent that. Force current on boat. So we're done with the current. And the earth always exerts a force downwards. So force earth on boat. Now let's take a look at this force diagram because I want to point out a couple things. First is that they all end with on boat, on boat, on boat. When we're drawing a force diagram, all of our forces should be exerted on our object of interest, which is in this case the boat. So all of our labels should end with force something on boat, okay? So that's good, that's one thing to check. We also want to check the length of our arrows here. Well, in this situation, our boat is not going to start moving in any direction, right? The dock is pulling it in, the current is pulling it out. So it's not moving in that horizontal direction, and that's why I draw these 2 arrows, the dock and the current, as equal length. Those 2 forces are balanced. Also, the boat is not going to start moving up or down, and that's why the force the water exerts on the boat and the force the earth exerts on the boat are balanced, and we're representing them by arrows that are the same length. So this is now a completed force diagram for our boat. But the next thing I want to do is I want to be able to write a sum of the forces statement. And we can see in this case, we have horizontal and vertical forces. So we're going to need a sum of the forces statement for the horizontal direction and for the vertical direction. Okay, so let's keep our positives and negatives that we had from our sketch and put them on our force diagram. Let's look at that horizontal direction first. Well, in the positive direction, we have here the force the current exerts on the boat. So I'm going to put positive force current on boat. And then negative, we have the force the dock exerts on the boat. So I'm going to put minus force dock on boat. Okay? And that's my completed sum of the forces for the horizontal direction. Now let's look at the vertical direction. In the positive, we have the force the water exerts on the boat. So I'm going to put positive force water on boat. And in the negative direction, we have the force the earth exerts on the boat. So I'm putting negative force earth on boat. And so now we have a completed force diagram with a sum of the forces statement based on it. So first I drew a sketch of my situation. I listed my variables. Then for each variable, I drew an arrow to represent the force that exerts. I added my positives and negatives. And then when I noticed that there are horizontal and vertical forces, I wrote a sum of the forces for the horizontal direction and for the vertical direction, making sure that my positives and negatives were correct. All right, let's try another example. Let's imagine that we have a block of ice. This is ice. And we have a seal sliding across the ice. This is a seal. I cannot draw a seal very well, so this is as good as it gets. And he's sliding to the right across the ice. All right, let's start making our force diagram. Okay, so we have our sketch. Now I'm going to circle my object of interest, which is the seal. Now let's list the objects that interact with the seal. Well, we have the ice. The ice is touching the seal. And of course, the earth is always exerting a force. And now I'm looking at this, and I see that those are the only two objects exerting a force on the seal. Even though the seal is moving to the right, there's nothing pushing the seal to the right. So I'm not going to include any other objects on this list. Okay? So now we're ready to make a force diagram. So let's look at the ice. The ice is pushing the seal up, right? That's what's keeping it from falling. So we have force ice on seal. Okay, so that's good. The earth, we always know, is exerting a force downward. So we have force earth on seal. Now let's add a positive and our negative. I'm going to label up as positive, down as negative. You could always do it the opposite way. It doesn't matter. Now, a lot of times when objects are moving, we're tempted to add an arrow here, okay? But we notice there is nothing pushing the seal. The seal is just continuing to move because it was already moving. So I'm not going to include an arrow there. This is actually our completed force diagram. You only add a horizontal arrow if there's something physically pushing it in the horizontal direction. There is no object pushing the seal in the horizontal direction. So I'm not adding anything like force motion on seal. I'm not adding anything like the ice is pushing it to the right, because that's not what's happening. I'm not adding any force at all to the right. The seal is just continuing to move because he was moving already. So there is no force exerted on the seal in the horizontal direction. This is a completed force diagram. So now we're ready to write our sum of the forces statement. And I recognize here there is no horizontal force exerted on the seal, so I'm not going to write a horizontal statement. If you want, you can put it's equal to 0. Now, we're only focusing on that vertical direction, so the sum of the forces in the y direction. So we look and we see our positive force is the force the ice exerts on the seal. So I'm putting positive force ice on seal. And our negative force is the force the earth exerts on the seal. So I'm putting minus force earth on seal. And now I am done, okay? This is a little bit of a tricky one, so I really want you to pay attention. An object can be moving. If it's moving in a constant velocity, it can be moving with no force pushing it to the right. If that's the case, it's just moving because it was already moving. And Newton's first law tells us that an object that is moving is going to keep moving with that same velocity unless a force is exerted on it. So we're not exerting any force in that direction of motion. So our force diagram does not have an arrow in the horizontal direction. So I sketched my situation, I wrote my variables, I drew an arrow for each of these, paying attention to what direction it should be in. Then I realized there are no forces in the horizontal direction, so I don't need a sum of the forces in the x direction. You can put it equal to 0. And then I did a sum of the forces in the y direction, checking that I have my positives and my negatives correct. Let's do one last example together. Let's say we have a person, let's say it's Lizbeth, and she's carrying her Christmas tree home with her. This is our tree, and they're on the ground. Okay, this should have been a flat ground. So our object of interest is going to be our tree. So I'm going to circle it. Now let's list the objects that interact with the tree. Well, we know that Lizbeth interacts with the tree. She's pulling it to the right. We know there's always the earth exerting a force on the tree. And I also know that the floor or the ground is exerting a force on the tree. And I'm looking and I see that it's touching the ground, it's touching Lizbeth, it's on the earth, there's no other force exerted. Okay, so let's start with our force diagram. Okay, so we have Lizbeth is pulling the tree to the right. So I'm putting an arrow to the right and labeling force Lizbeth on tree. Done with that. Let's also add our positives and negatives while we're at it. Okay. Now earth, I know, is always pulling a force down. Force earth on tree. Okay. Now the floor is exerting a force up, so this is going to be force floor on tree. Let's put in our positives and negatives. And I notice here that the force the earth exerts on the tree is balanced by the force the floor exerts on the tree. The tree is not going to start moving up or down, so I made those arrows the same length. Now let's write a sum of the forces statement. We have both horizontal and vertical forces, so I'm going to write a sum of the forces for each. Let's start with horizontal. So in our horizontal direction, we only have one force, and it's that positive force that Lizbeth exerts on the tree. Okay, so that's it. I'm done with my horizontal forces. There is no force in the negative direction, so I'm not including anything. Now I have my sum of the forces in the y direction. So in the positive direction, I have the force the floor exerts on the tree. So I'm putting positive force floor on tree. And in the negative direction, I have the force the earth exerts on the tree. So I'm putting minus force earth on tree. Okay. So here I have my horizontal forces. It's just the force Lizbeth exerts on the tree. And my vertical forces are the force the floor exerts on the tree in the positive direction, and in the negative direction, the force the earth exerts on the tree. So again, I always go through that same process. I sketch my situation, circle my object of interest. I list the objects that interact with that object of interest. I draw an arrow for each of them to make a force diagram, making sure your arrow is in the right direction and it's the appropriate length. And then I write a sum of the forces in the horizontal and vertical direction, making sure to take into account the positives and negatives. So that's our video on how to draw a force diagram and write a sum of the forces statement. Hopefully it was helpful to you. If you have any questions, please send me an email or message me through Remind.